Okay, let's continue on with the lesson with the greatest common factor. What is the greatest common factor? The greatest common factor is when you have multiple numbers and you want to find the biggest number that divides evenly into all three numbers at the same time. Okay? The way to do that, okay, is the definition of it is the prime numbers, prime factors that are common to each number. Okay? Then you multiply them together. And then you multiply. Okay? Then, if you have a monomial, then you have to worry about the common variables, vars, 2. Still multiplying them together. And finally, if there's nothing in common, then your greatest common factor is 1, and that has a special name. When that happens, your terms are said to be relatively prime. They may not be prime numbers in and of themselves, but when you put them together as a list of numbers, and then you try to find the greatest common factor, and the only common factor is 1, then those numbers are called relatively prime numbers, but only in relation to each other. Okay, let's take an example of that. Let's say in your book, example 5 says, what if I had numbers 15 and the number 16? That's an and sign, not a plus sign. Okay? And I want to know the greatest common factor. Well, I'm going to do prime factors of each one, and I'm going to put them in the factored form. So this is 3 times 5. That's done. And this one is 4 times 4, and then 2 times 2, and 2 times 2. And so I look at the factored form of each of these, 3 times 5, and 2 times 2 times 2 times 2, and I see that I have nothing in common. So since I have nothing in common, my greatest common factor is 1, and these guys are relatively prime. 15 and 16 are relatively prime. Now let's try example B5b, where we're using monomials. Let's say 36 x squared y and 54 xy squared z. Okay, now what we have to do here is do the prime factorization of each number and each monomial. So first let's do the number 6 times 6 and 2 times 3 and 2 times 3. So we now know that this guy is 2 times 2 times 3 times 3, and then we add in the variables x times y. So there's the factored form of that guy, prime factor. Let's do 54. We do 2 and 27, and then 3 and 9, and then 3 and 3. So this guy gets to be 2 times 3 times 3 times 3, and then we do the variables x, y has to appear twice, and z. So now we need to find the common factors. Well, there's a 2 and there's a 2. There's a 3 and a 3, 3 and a 3. There's an x and an x, and there's a y and a y, and we've used up. There's no other ones. So this guy gets to be 2. I'm just looking at the underlined items now on one side. 2 times 3 times 3 times x times y. And so the greatest common factor of 36 x squared y and 54 x y squared z is 2 times 3, which is 6, times 3 is 18, xy. And there's the GCF for those two. you can divide that number into both of those and reduce them. Okay. Now let's take a look at example 6. In example 6, they're asking us to do a little bit of geometry, but they're saying take in the number 28 and factor it. Okay? It doesn't say prime factor, it says factor it. So I'm going to use the factor table that we looked at the beginning of the lesson. I'm going to start with 1 and 28. I'm going to factor this out. 2 and 14. 3 doesn't work. 4 works. 4 times 7 is 28. 5, nothing. 6, nothing. 7. Well, if I'm on 7 on this side, but I've already got a 7 here, that means I'm done with my factorization. So these are the factors of 28. 1, 2, 4, 7, 14, 28. Now the problem says if I was to draw for each one of these pairs of factors a box model and a rectangle that was 1 high and 28 long, what would be the perimeter of that guy? Well, the perimeter would be 1 plus 28 plus 1 plus 28. And 29 and 29 is 58. Okay? Well, then they said draw a box model of this guy. Well, this one would be half as long and twice as high, so 2 times 14. So the perimeter of this guy would be 2 plus 14 plus 2 plus 14, which is 16 and 16 is 32. And then finally, for 4 and 7, be twice as tall again and half as short. 4 and 7. So this perimeter is 4 plus 7 plus 4 plus 7. And that's 11 and 11, 22. And the question originally asked us which one of these perimeters is the largest. And there is the largest perimeter. 1 and 28 makes the biggest perimeter of the factors of 28.